If we have a function, I'm going to call this function f of x, and we're going to, we want to integrate f of x between a and b. That would mean that we're really finding the area between a and b underneath the curve. We've done that in a previous video. What would it look like now if I introduced a second function? Let's call it g of x. And instead of finding the red area, I actually want to find the area between these two curves, between a and b. So the green. Well, there's two steps to this. The first step is that you find the area underneath the curve of f, and then you find the area under the curve of g of x, which would be, do that in orange because it's under the orange curve. And notice that the green area and the orange area are the red area, and if you want to find just the area of the green, which, let me just highlight that a little bit more clearly. Oh, in green. Let's try that again. If you want just this, then you would find the area of the red, which is all of this, and subtract the area of the orange, which is this. And we do that using integrals. So what we're really looking at is if we want the green area, we take the integral of the f function between a and b and subtract the integral of the g function between a and b. And that's what we're going to be looking at in this lesson. And what this is a pretty simple diagram. I'm just going to go over the basic concept if the diagram is a little bit more complicated. So let's do a second diagram here and imagine what would happen if you had a curve like this called f of x and a curve like this called g of x, and you want to find the area in between. So it's very similar to the last question, except this time I haven't given you the a and the b. You notice in the last example, in this example I defined the left hand and the right hand bound, but in this one I haven't. I just said the area in between. So your first job would always be to find these 2 points, and that's to find where these two curves intersect. So you'd have to find these first, then you have to find the area in between, which would be the integral of f of x minus the integral of g of x. So that's an added wrinkle. The other thing to consider is here the f of x function was all above the g of x function for the entire piece between a and b. What happens if that isn't the case? For example, if we have let me insert a new diagram here. If we have a diagram that looks like this. So we have a function like that. We'll call this one f of x. And then we have a g function that looks like this. And I want to find the area in between these two curves. So notice in the first one piece here, it's the g function that is on top. And for the second piece, which is in purple here, it is the f functions that's on top. So what we need to do is, number one, find all 3 intersection points, and then do 2 separate calculations. We're going to do the red one first. So the red one area would be the integral of g of x, because that's on top between a and b, minus the integral of f of x, because that's the one on the bottom between a and b. And then we'll do the area of the second area, the purple area, color coding it here. That's where the f of x is on top. See, this is on top, and that's between b and c, minus the one on the bottom, which is between b and c, but it's the g function. I should have dx is all the way around here. So that you have to be a little bit careful it's always best to start with a diagram of the function before you start to figure out the area of the curve, because it's important to figure which function's on top and where it switches. So one last thing to consider is what happens if it goes below the x-axis. So let's do one more diagram this time. I'm going to do, here's my f of x, and let's say I do g of x like this, and I want to calculate the area between 0 and a between these two curves. So that's all of this and all of this, and add these two together. So it depends on, if you actually want physically the area, then you have to calculate the area of f of x underneath the curve, so that's between 0 and a. And then you calculate the integral of g of x, let's call this one g of x here, between 0 and a. Now what's going to happen to the integral between 0 and a? It's below the x-axis, so it's going to be negative. And if you physically want the area for this, then you have to subtract it as well, because you want to make this negative a positive, so that when you're adding, you're going to add the two areas. So that's how that works. Now in the next videos, we're actually going to do some examples with given functions.